Now that you know how to balance chemical equations, it's time to be able to predict what type of products will be formed when two or more reactants combine chemically. We're going to go through different types of chemical reactions. The first type is called synthesis or direct combination. It's when you take two elements that are by themselves and you combine them to make a much larger compound. A plus B yields AB. What you can see is this example. Sodium and chlorine, both being by themselves, combine to make sodium chloride. Throughout all of these chemical equations that we're going to talk about, I'm not going to take the time to balance them. I'm just showing you how you can predict the products. The next type of reaction is called decomposition. It's the exact opposite of synthesis. This is where we take a larger compound and break it apart. An example would be to take carbonic acid, H2CO3, and break it apart into water and carbon dioxide. Notice that we have one compound on the left side of the equation and two compounds on the right side, a good indication of a decomposition reaction. The next type of reaction is called single replacement. I like to refer to this as the loser at the dance. As you can see here, the element A is by itself and the element B is paired up with something within a compound. What you see is that A kicks B out of the dance with X and B is left by itself. The reason why this happens is that A is more reactive than B. If B is more reactive than A, then X will choose B over A and nothing will happen. But if A is more reactive than B, then they will switch places. Let's take a look. I've made A red and B green and X blue. And you can see in the example here, if I take magnesium and react it with hydrochloric acid, magnesium an element, hydrochloric acid a compound, the magnesium is more reactive than the hydrogen and will replace it and react with the chlorine, and the hydrogen gets kicked out by itself. Now notice that hydrogen by itself is diatomic, as we covered in the last podcast. Also notice that the equation is still not balanced. You would have to go back and balance the chemical equation. The next type of reaction is called a double replacement reaction. This is where A and B are both paired up in compounds, and they switch places with each other to go with the other substance within the compound. You can see that A is red and B is green, and follow along as we go through this example. If we take sodium hydroxide and react it with calcium bromide, you'll notice that the sodium is with hydroxide on the reactant side. But if you look, sodium will want to go with the bromide on the other side. So the sodium and calcium have changed places. The calcium that was with the bromide is actually now going to go with the hydroxide and form calcium hydroxide. Notice I still had to write the formulas so that they were neutral. In order to get calcium hydroxide to be neutral, we have to have one calcium which is a positive 2 charge and two hydroxides which are a negative 1 charge. The sodium bromide, the sodium has a +1 and the bromide has a -1. That's why it is a 1-to-1 ratio. The next type of reaction is called combustion. This is when you take any substance and react it with oxygen. In this podcast, we're just going to cover hydrocarbons, which are nothing more than substances made out of only carbon and hydrogen. You'll notice in a combustion reaction that oxygen, water, and carbon dioxide are stagnant. They are always within the equation. The only thing that will change will be the hydrocarbon. Our example will be methane, CH4. If I react methane, I'll form water and carbon dioxide.